What are you doing here? Alrighty. So, talking more about inheritance. What do public and private mean in terms of inheritance? Normally, we think of private data as accessible only to the class in which it's defined, or private methods can only be called from within the class in which it's defined. Public, so I should say members, right? A private member is accessible only to the class. Public members are how do you spell accessible? Alrighty, how about that? Everywhere. Does that mean that a private member is available to all of the child classes, to all of the subclasses? And the answer actually, and surprisingly, is no. There's a third category called protected. A protected member is available only to the class and its subclasses, the classes that inherit from it. So let's say that we're going to write a class called Pokemon. And it really only has right now maybe a couple of pieces of data. One is a name, and the name of the Pokemon itself, and its current health, how many health points it has, something like that, which we can use as an int. And let's define a constructor that will use that will create it. Alrighty, so public Pokemon, and it's going to accept the name and the number of health points as its values. So this dot name equals name, this dot health equals health. That's its constructor. We didn't set, though, whether these things were public or private. Just for funsies, I don't know why it would be so fun, but let's say that these are going to be private, just to make it a challenge to ourselves, right? Just to make things a little bit harder to use. So we're going to make a class called Fire Pokemon, right? All the different Fire Pokemon are Pokemon. Hopefully, anybody watching this knows what a Pokemon is, and you can have like Charizard, who's a Fire Pokemon, and you can have, another kind who's a Water Pokemon, and so on. So class Waterpoke extends the Pokemon class. And it has special ability to deal water attacks. So I don't know how that takes play into this yet. I haven't figured that out, but let's go ahead and create a constructor for this, right? So public Waterpoke, and it needs to take a name. I guess we could have a third variable up here called type, and Water Pokemon would set its type to water, right? So private string type. So along with the Pokemon's name and its health, it needs a type. And we can set this dot type equal to type. I am surprised that type is a legal word. That sounds like a programming word, right? Sounds like a keyword, but apparently it's not. So his constructor doesn't need to pass in a type, but it does definitely need a name and a health. And it needs to call the super constructor in order to pass in the name, health, and the type. And we can't just do this dot name equals name here. Why? Because this is protected. Or it's not protected, it's private. Name is private, meaning that even the child classes, the classes that inherit from it, aren't able to use it. If I want to be able to access it, I would have to change that word private to public. So instead, we're going to call the constructor super, and we're going to pass in the name and the health, and the type is water. And then lastly, we're going to create, I should not make a water Pokemon. I don't even remember the names of any of the water Pokemon. I'm feeling pretty lame here. Bulbasaur. Yeah, he's a water Pokemon. So now we're going to make a specific kind of Pokemon called Bulbasaur, who is a water Pokemon. So class Bulbasaur extends water poke. And we already know his name, so we don't even need to have a constructor that takes the name. And we're going to say that all Bulbasaurs have 100 health, so we're not going to accept that in our constructor either. So all we need to do is to write a default constructor that calls this super constructor, which will call that one. So it doesn't need to accept any parameters. So public Bulbasaur, and it calls a super constructor, passing in the name, which is Bulbasaur, the health. Bulbasaurs have 100 hit points. And we don't even need to pacify the type because all water Pokemon, all Bulbasaurs are water Pokemon. And so just so that we can kind of keep track a little bit of what's going on here, I'm going to add some just kind of debuggy print statements. I am a Bulbasaur, or creating Bulbasaur. And I'm just going to copy and paste that into my other constructor so that it prints additional information out. So creating a water Pokemon. And then the water Pokemon's constructor calls this one creating Pokemon, right? So a Bulbasaur is a water Pokemon who is a Pokemon. That's the hierarchy. He's the superclass of them all. This is the superclass for that one. So this is a subclass to that one that is a subclass to that one. So the name and the health and the type are all private to this thing. And I wonder why we're getting errors here. The field name can be final. Well, I'm just going to leave that alone. I believe it's true because nothing can change it. I'm okay with setting that to final because his change isn't going to change. His name isn't going to change in the middle of battle. Neither is his type. However, his health can go down. If he takes hits, his health will go down. So we'll probably need to add some kind of method here to cause the, him to take hits. I'm not even sure I'm going to get that far, but let's go ahead and make a Bulbasaur. So down here in main, this is our client class, completely separate from all of these classes, which really should be in their own files. We should have a Pokemon.java, a waterpoke.java, and a Bulbasaur.java. Down in here, we're going to make Bulbasaur. Bulbasaur Bulba equals new Bulbasaur. And so if we were going to make this more complicated, the Bulbasaur would probably have different kinds of attacks, and each different kind of attack would do a certain kind of damage based on what it was attacking, something like that. I don't really want to do that, but why don't we add two more methods to the Pokemon class, one that returns the health so that we could tell how many hits the thing has left, and another one that will reduce its health if it takes damage, right? So public void damage, it's going to take a certain number of points of damage, and it's going to reduce its health by that much, right? So health minus equals damage, but if it drops to 0, that's it. We don't need to print a damage. What am I doing here? I guess I should have called that damage right there. All right, but we don't want it to get less than 0, right? So health is equal to, can I do this math.minimum? Or the max of either the current health or 0, whichever is higher. That way, if it drops below 0, it'll round it back up to 0. It's just a way of doing it in one statement rather than writing if health less than 0, set it to 0. We could also have written that as a conditional if. Right, we could have written health equals is health less than 0, question mark if it is, and set it equal to 0, else set it to its previous health. That looks a little bit more cryptic to me than this way of doing it, so I'm going to leave it like that. And since we want the Pokemon to be able to generate an attack, well, that'll be customized based on the particular thing. The Bulbasaur needs to be the one generating the attack. However, all of them can attack, so we need to create some kind of method that the rest of these extend in order to generate the attack. So this is going to be probably an empty method. It doesn't even need a body. We just need to define it, right? So public int attack, like that. And we're going to get an error because it doesn't have a body. So we need to declare it as abstract. An abstract method is one that doesn't have a body that will be implemented later. So this must be implemented in a child class, in a subclass. Now we have another little warning coming up saying that this class, since it has an abstract method, it has to be declared as abstract. And once this is declared as abstract, that means that it's impossible to create this class. We can only create subclasses from it. We cannot instantiate the Pokemon class because it is marked as abstract. Why can't we do it? Because there's a method in here without a body. And so if we come down here and we do Pokemon P equals new Pokemon, I'm going to delete this in a minute. I wish I could type fast enough. Equals new Pokemon, right? It's going to say it's an abstract class and cannot be instantiated. All right, so I know better. I'm not going to try to do that. Well, now we have a new problem. Trickle-down problems. Water Pokemon doesn't implement this class, this method either. And so we either have to make water Pokemon implement the attack method, or we need to mark it as abstract as well. Because it's kind of the middleman, right? It's halfway between our specific kind of critter and the root Pokemon class, and it doesn't bother to implement the attack method, so it needs to pass the buck along. So he's marking himself as abstract as well. However, Bulbasaur, we do want to be able to instantiate a Bulbasaur, so we have to create that attack method. So he's posting an error about it, and if I just click on it and say implement the abstract methods, there it is. And all I need to do is to make it return what it's supposed to do, right? Return whatever value it needs to do. So public int attack, and we're going to say that Bulbasaur does 20 points of damage each attack. Or we could make it random or make it based on its type versus the type that it's attacking. We could get real complicated, but why don't we just leave it like that? When he attacks, he does 20 points of damage. Okay. So I'm not even sure how much to do with this. What else would I do? According to my little rules of making classes, it sure would be nice if we had a toString method so that we could print out information about the Pokemon. And we have several bits of information that are worth printing, right? So why don't we add a toString method to the Pokemon class? Public string toString. And so it's going to, string is equal to the name of the Pokemon, this dot name, plus a parentheses, health equals, end parentheses, plus health, right? Oh, I forgot to give a name to the string variable. And then s plus equals a comma, type equals, end quote, plus type, plus a closing parentheses. I probably should have used string format. It's probably really stupid to do it that way. So I'm going to erase that and replace it with string format. String s equals string dot format, open parentheses, quote, %s for a name, and then parentheses his type. Type equals %s, health equals %d, end quote. And now we need to fill in those parameters. So after the quote and the comma, fill in this dot name, comma, or I don't even need this reference if I don't know the names of the variables. Name, health. Nope, wrong order. Name, type, and health. Then return that string. Alrighty, now that we've got a Pokemon, it just wants us to add the override annotation. So this method here, toString, is available to every Pokemon that inherits it. So if I try to print out the Bulbasaur, it's going to call toString for the root class, the ultimate superclass Pokemon. Although really the root class is object. Everything inherits from the object class, but this is our root class, the one that we've defined. So let's go down and get his attack, right? Int attack equals bulba dot attack, parentheses, end parentheses. And then let's print the Bulbasaur out. So system.out.println parentheses quote. Don't even need that. Oh, come on. All right. We can just print out the Bulbasaur itself. Bulba. And then maybe he's going to take a certain number of hits, right? Int damage is equal to, you know, he took some kind of damage, I don't know what, from whatever. And then so he's got to take those hits. So bulba dot damage based on that many number of hits. And then we're going to print them out. All right. So when we created them, first it ran the super constructor at the top of the hierarchy chain, the Pokemon's constructor. And it did that because this constructor called that one, which called that one. Wouldn't it be neat if we could change the order, you know, of that so that this print statement was in front of the call to the super constructor? I would do that, except the superconstructor has to be the very first call inside a constructor. So I can't even put a print statement in front of that. Well, anyways, and so after the attack, you know, he had 100 hit points, but he took 35 damage, and so he dropped to 65. Looks like my toString method is missing a parentheses at the end. And when we do this damage, why don't we print what just happened, right? So system.out.print f parentheses quote %s for the name takes %d damage health equals %d \n. Now we need to fill in those placeholders with the name of the Pokemon, the amount of damage it took, and the health left. All right, someone's here. Hi, Lindy. So
Hey.
Go ahead and run it. And we'll see that the Bulbasaur was created. And then he took some hits. He took 35 hits. And so his health at that point was 65. And then we printed his state information out. So, Lindy, I don't know at which point you joined in. Were you here for the creation of the classes?
Yeah, I was just a few minutes late, so I think you had just created the project. It's working fine, so I don't think I missed anything.
Oh, okay. You're typing it in as we went. Okay, great. So I don't
Yeah.
need to slowly scroll up and down explaining things. Okay, cool.
No, I'm good.
All right. So that is an example of a couple of things. One is that this data is so tightly encapsulated by being set to private that these things down here don't even have access to it. He doesn't even know his own name, right? We can't call a get name or dot name. If we wanted to print out his name, system.out.println, this dot name, he can't do that because it's private. If we wanted to make him able to do that, we would change it to protected, or we would provide getters and setters. So why might we want to do that? Why might we want to make all these things safe? Just so that we can't accidentally mess it up, and the Bulbasaur can't be changing things it shouldn't. We shouldn't be changing the Pokemon's name on the fly, and we shouldn't be changing the Pokemon's type on the fly, and we shouldn't be manipulating his health directly. The only way that the health should be modified is through function calls like damage and heal, right? We might go and add another method to the root class called heal that would add some health back to it, something like that. So we never even added any getters and setters to these things. But if it turns out that the child classes, the subclasses, do need access to them, we could either make them protected or we could provide getters and setters, and we could do so very selectively. Like we might just make getters and not setters so that the things down underneath would be able to get them. Or maybe the client code needs to be able to access the name and the health and the type, right? And so maybe we need to add some getters without setters. And that's as easy as highlighting those guys, choosing refactor, encapsulate, and saying, please make me some getters, but no setters. I wonder why these were already marked off as grayed out. And its funny little brain, it didn't want me to, because those are marked as final, right? So they can't be changed. So we would not mark, so we can't call, we couldn't not make setters for them. They're final. Health is not final because it's supposed to change, so it's not a constant, but we're not going to allow any child classes or the client code to change those values. Now, when I do this, it's going to stick the getters in the wrong place. It's going to stick them up at the top rather than at the bottom. And it's going to add all sorts of nasty comments. So, excellent comments. So I could do it that way, but it probably won't take much more time just to type them in. So public int get health, return this dot health, right? And then public string get name, return this dot name. Putting my semicolon in the wrong place. So easy to do when I do this one line version. And then public string get type. Return this dot type. Semicolon. Now I can't argue that it would be better or worse to provide getters or just to mark these final things as protected. Since they are already marked as final, that means that nobody else is going to be changing them. So they are kind of safe anyways, right? So I didn't necessarily have to provide accessors for them. I could have made them protected, and then the subclasses could get a hold of them. However, the main method outside of this, the client code, would not be able to access them at all. So I'm comfortable with the way we've done this. Any questions over this idea? I'm not planning on enhancing it further, but I'm hoping that that demonstrates extending something that extends something, right? We've got, Bulbasaur extending water Pokemon, extending, the base Pokemon class. And we've demonstrated, oh, look at that. Is that error going to go away when I build it? No. It doesn't like something about these methods in front of it, because if I cut them, the error is going to go away, right? Oh, there's a semicolon there now where there wasn't before. How'd that get there? Because I touched my keypad accidentally while typing. All right, no semicolon on the add override. All righty. Any questions over this particular example?
The protected class type. We never used protected keyword.
Yeah. If I made a protected method, then that means that the child classes can access it. Like maybe every time we do an attack, our fatigue goes up by 1, right? So this dot fatigue plus plus, he's able to change that. However, protected is not public. So down here, Bulbasaur, we would not be able to change his fatigue from down here. Make a liar out of me. Then what in the world does protected even mean? Oh my. I think I hit this in a previous semester and it blew my mind so bad that I forgot it. The orthodoxy that I've learned for 30 years is that you make a protected variable so that it cannot be changed by client code. Maybe it would be if it was in its own Java file. I'm going to try that. I'm going to try cutting this out and putting it in its own file. So I cut the entire Pokemon class. This is a wild guess. find out. I'm seeing an error indicator over here. Maybe that was the trick. No. What is protected keyword in Java do? Protected keywords, well, are keywords. It's actually not correctly good syntax for it. What are protected members? Access modifier used for attributes, methods, and constructors, making them accessible to the same package and subclasses. All righty. Well, then, what are all the Java access modifiers? I just want a list of them. Okay, so all of them are accessible to everything else in the same package. And that's kind of news to me. I guess I was relying upon my C++ news. And so for the past 10 years, I've taught Java incorrectly and said that protected stuff could not be modified by the client code. The only way to absolutely, or by the subchildren, the only way to keep something absolutely safe is to mark it as private. If you don't give it a type at all, it can be modified by the class and anything in that class, but not the subchild. What happens if we don't do that at all? I don't see any difference between protected and default. They still allow the main class to modify it. As far as I can tell, the only way to stop the client code from modifying it is to put it in its own package. All right, so Troy, feel free to rephrase your question about protected, because I'm finding it to be completely useless. The only thing it does is make it so that if we were in another package, things would not be able to modify it. So if we stuck this class inside another package, then main would not be able to touch it.
I guess just don't touch it then.
Right, right. So the real thing to do would be to make it private and then add a setter, right? Or something that would increment it each time. So I'm just going to leave it like that, I think. Rather than go and create a separate package and move all that stuff to a separate package just to make my demo work. But that does mean that I have some comments in here that are incorrect. I may just delete them entirely. Oh, I didn't actually mention what public and private do, so good. I'm saying, well, that's idle. All right, let's leave that alone. So what I should do is I should make that variable private as well. And then write a function that adds 1 to fatigue each time, right? So public void increment fatigue. Or fatigue add, or whatever, right? And so it's going to take an amount and it's going to add that much to fatigue. This dot fatigue plus equals X. And since it has been declared as private, I ding ding expect to see some errors over here now. Yes, I do. So I'll go over here and fix those. The attack cannot access it directly. So we will call this dot increment fatigue. Attack, it increases its fatigue by 1, so it gets more and more tired for whatever purposes. And down here, he definitely cannot change the fatigue. All right, I want to go look for something. All right, so an assignment that I want to give y'all, it's called Piggy Bank. Notice that this is the apprentice version because it's simpler than an upcoming assignment, which requires the coins to be classes, not double values. So write a program that simulates a piggy bank. And this one's not even actually in doing object-oriented stuff, unfortunately, or what I should say is inheritance. As you know, a piggy bank is a coin bank shaped like an animal. The program will prompt the user for what kind of coins to add and add that to the bank, and then tell the user how many coins and their total values. So your program needs to have 2 classes, a piggy bank class and a client class with a main method. So the piggy bank inside it needs an array list of coins to keep track of how many coins have been added to it. And so this list variable can be called coin list. And the piggy bank needs an add coin value, add coin method, which will add that coin to the array list. And the piggy bank class also needs methods that show how many coins are in the bank and how much money is in the bank. The class should not allow the user to put more than 50 coins in the bank. So in the end, your program should accept coins of the values for pennies, nickels, dimes, and quarters. So you can ask the user what type of coin they want to add, and they can type in penny, nickel, dime, or quarter, and it'll add 1 coin of that value to the bank. So the piggy bank class could have a coin list of type double, each coin, holding a double value. And then get total money, get the number of coins, and add a coin to it. Now, add coin could return a number indicating how many coins were successfully added. For example, if we tell it that we want to insert 60 pennies, but we've already said that the piggy bank can only hold a maximum of 50 coins, then it would return 50 rather than 60, saying that, oh, I only managed to insert 50 out of 60. So when we call added, but that doesn't look right. This example is wrong then. This does not match this. What are we going to do about that? Well, I'm going to have to modify it before I upload it. So we're not going to return true or false. Instead, we're going to return the number that was actually added, and then we can compare it. So a sample run for an incomplete program that only supports 2 coin types. What kind of coin do you want to add? A penny or a dime or quit? Okay, the coin was added. The bank contains 1 coins. If you feel like making it check, to see 1 versus 2, whether to make it plural or singular, great. Worth $1. Again, with it. What kind of coin to add? They add a dime. Okay, coin added. And so it's got both a penny and a dime in it. So I would use a switch statement to translate the coin type to a value. So this is the one that doesn't use inheritance or anything like that. There's another version of it that does use inheritance. And so it's kind of a part 2. Hope I can find it real fast, where you have a coin class. And the coin class is used to build coins. So let's see if we can find that one. I hope I didn't lose it during the transition from D2L to Canvas. Well, I'm not going to look too much for it because I can rewrite it if need be. So this is the piggy bank assignment. It's a little interesting one, I think. So I will post that, of course. Are there any questions about this as it's presented to you? You can see that it doesn't use, inheritance in any fashion unless you really tried hard to shoehorn inheritance into it.
No questions right now.
All right. So if we were going to change it to be an object-oriented solution, the next change is going to be, and I'll flesh this out a little bit more carefully, modify your piggy bank project to have an abstract class called coin, and you have a penny, dime, quarter, nickel, which is correct. And, penny, dime, quarter. Guess that's enough, right? Classes that extend the coin class. The coin class has a data member called value, right? And then the subclasses need to set that value. And then so when it asks when you ask the user what kind of coin to create, you do something like this, right? Coin C equals new coin. But in this case, we're going to do a new dime. And then we're going to do bank.add, and we're going to add our coin to it. And how many coins we're going to add? 10, right? And so behind the scenes, it'll go ahead and, do what it needs to do. So the add method will be modified to accept an object of coin class and to get the value, the numeric, money value of that in order to add that onto the linked list, to the string list, array list, excuse me. So that's part 2. And I'll write that one up and present it on Thursday so we don't have to do all this, all this today. So does that part make sense? Modifying it a little bit so that this project will also support a coin class, and the coin class can be used to derive other coins from it. You want a $1 coin or a 50-cent piece or whatever, you can do that as well. And then you'll just modify the add coin method to not take. I'm definitely going to modify this because I want to make it so that you pass in the number of coins. So it should have been add coins. This is an older version of it. I've seemed to have lost a newer one. Add coins needs to take both the value and the number of coins to add. So it needs a few edits to be a correct homework assignment. So I'm not going to change it from what I talked about. I had assumed that that was actually in there, but the examples need to be modified a little bit, right? Because we're going to add a 10-cent piece to it, but how many are we going to add, right? We're going to add 5, or we're going to add 1 or something. So it needs an extra parameter there. All right. Let's go and look here. Using super to call the superclass constructor. We've done that for a couple of days. Calling a superclass's method from within a subclass. As you recall, in an instance method, if you call a method that's in the same class, you don't have to use the dot prefix. You don't have to use, a dot in front of it. Likewise, in an instance method, if you call a method that's in the superclass, you don't need a dot in order to call it. So if our Pokemon class has a getName method, which it does, and we feel like printing out its name in a subclass, we can do so. We just call getName, right? We don't have to find some sneaky way of referencing which object we are in. Or you could just type this dot getName, because when you type in a method name or an attribute name, it'll go up the hierarchy looking for something of that name in order to link to it. Method overriding, we've been doing that. Method overriding is when a subclass is a method that replaces a method that's higher up. It's not overloading, it's overriding. We did that here. We had a damage method here. Wait, no, we had an attack method here that was declared but not implemented. And so in the subclass which actually needs to generate the attack, the Bulbasaur subclass, he had to provide a body for it. And so he overrode that other definition of it. And to do an override, it has to have the same name and the same exact return type and parameter list. And we see that at override notation every time we do a toString method. And if we added a dot equals method, we would see it there as well. So the final access modifier, if you want to specify that a method definition cannot be overridden, you can mark that method as final. So if I wanted to, and I can't really think of a reason why, but if I wanted to make sure that nothing could replace, nothing could override getName or getType, then I can mark them as final. That just disallows, it forbids the water Pokemon class or the Bulbasaur class from any programmer adding a getName or a getType method to those. The only ones that should be used are the ones that are in the root class, the superclass. Why would you want to use final? If you think your method is perfect, then you might want to use final to prevent anyone from overriding it. Final methods might run faster. The compiler can generate more efficient bytecode for them because it doesn't have to prepare for the possibility of inheritance. If you want to specify that a class cannot have any subclasses, you can mark it as final. So I couldn't make water Pokemon final because we definitely need to be able to extend it, right? However, Bulbasaur might be a final class. We're not going to inherit anything from Bulbasaur. So we better add some comments about what's going on there. Where are our comments? Okay. Making a method final, or let's do this. Making a variable final makes it a constant that cannot change. It's like the meaning of final differs based on where it's used. Making a method final marks it as a method that cannot be overridden in a subclass. And making a class final marks it as a class that cannot be extended. So aggregation, composition, and inheritance compared. Inheritance is a relationship. A Bulbasaur is a water Pokemon. Composition is when you have data that is exclusively owned by one class. And aggregation is when you have data that can be shared between classes. Now, our example right here, all the data is owned by the class completely, so it's all composition. Our Pokemon is composed of a name and a health and a type and a fatigue, right? It's got 4 attributes. It's the sole owner of those things. So there's no aggregation involved. So a composition relationship is a Pokemon has a name, a Pokemon has a health. And inheritance is an is-a. So a manager and a salesperson are probably both subclasses of a employee superclass, but that's not represented here. What is he asking here? In the real world, it's fairly common to have aggregation, composition, and inheritance in the same program. For example, what sort of inheritance relationship below could be added to our earlier dealership? Well, they sure do have a lot of little comments here and boxes implying that they're going to talk about it, and then they don't. So I don't know where this slide's going. Now let's take a look at this. A card game, UML. We have a card class. Each card has a number, right? You can have a 2 of hearts and a suit, right? And the suit is the hearts or the spades and the clubs or whatever. And then you have something that'll print it out. Now, a group of cards is an array of cards, or maybe it's a list of cards, but whatever, right? And then you have a current size, which is however many are in that cards. If you want to add a card to it, you have a method needs to add a card. And then you need to be able to display your group of cards. And then a deck is a group of cards, right? And it has a couple of methods. Shuffle, to shuffle the cards in the deck, and deal, to get a card out of the deck. And then you have a hand, which is also a group of cards. You can sort your hand, or you can play a card. And then you have a game. The game has a deck of cards, and player 1 has a hand, and player 2 has a hand. And then it's got a method that actually plays the game. So out of all this, we can see that a group of cards uses the card class. And so this is composition, right? Now, if you could somehow simultaneously have a deck of cards and a hand that had the same card in it, then it would not be composition, it would be aggregation, and you would use a different shape. You'd use the hollow diamond to indicate that. But each card is owned only by one deck, right? One group, so it's a one relationship. But that group of cards can consist of as many cards as necessary, right? It can be just one card, or it could be 52 cards, and so that means many, right? More than one. And a deck is a group, and so the arrow comes up here to indicate that a deck is a group, and a hand is a group. This is an is-a relationship. So deck extends group of cards, and hand extends group of cards. Now, you might have thought that maybe a deck has a group of cards, and that a hand has a group of cards. Maybe group of cards should have been made a member of these classes rather than use inheritance. So I don't have a good strong reason for why you would want to implement it as a is-a or a has-a relationship, right? A deck has a group of cards and a hand has a group, or a deck is a group and a hand is a group. The only thing that I could see needing that for is if there are methods that are going to be shared between both of them. Add card, we could add things to our deck and we could add things to our hand. I don't know about adding cards to a deck, but sure. And then display. We want to be able to display our group of cards. Well, that's a good one to have. So, I accept that this is a possible way of implementing. I'm not profoundly convinced that this class is so cool that it needed to be done with inheritance rather than composition. The critter class. Okay, that's more examples. Way more examples. All right. In the book, what is used as an example for composition hierarchy? A human body, because we had cells that were part of muscles, and the body had different kinds of tissues, which were were muscles and this and that and the other, and they had cells, and cells had mitochondria. So it was human body. I believe that was the example. I could be wrong. And then what word indicates that a class is derived from another class? Extends. What is it called when a subclass has a method with the same name? I'll let y'all pick this one. If you have a method with the same name and same parameter types, is that overloading or overriding? We know that it's not reliance and catering, but if I wanted to make this a good quiz question, I would have made one of these overriding and the other one overloading. And what's the difference? Overriding is when the method has the same name and the same parameter types, and so it has to be put in a superclass. And overloading is when it has the same name but different types. And then what public access can you use? I like this one, unique, to prevent someone from making a subclass from the existing class? Final. Yeah, that one's pretty ridiculous. I like catering up here too. That's a good answer. All right, and then which of the following, I don't care about their examples or not. I care about our examples. Let's go look at our quizzes here. Quiz over chapter 13. Ooh, it says for 13 and 14, so I guess I can go ahead and publish it, but supposedly we would have to go through chapter 14 for it to make more sense. Let's go and look to see what's coming up in chapter 14 to see why I did that. I may want to reverse that and modify the quiz. Let's go look. All right, inheritance and polymorphism. All right, we've already talked a lot about this stuff. We've talked about equals. We've talked about toString. We talked a little bit about polymorphism, right? Polymorphism is when you have different objects that can be treated as the same, since they all either implement the same interface or all extend the same class. And then compilation details and polymorphism with arrays and abstract methods and classes. So we've talked about almost the entirety of chapter 14 already. So I'm curious how well we would do if I made us take that quiz right dang now. I'm going to go and look at that quiz, preview it. I mean, it's not going to be due, right? But it's going to be open so that you can take a look at it. Let's go take a look. All right. Using the concept of inheritance, match the descriptions. Hints. All right. I'm going to ignore the hints. So the class that the other class extends from is what? The superclass or the subclass? If we extend from something, which class is that?
Super.
Yeah, it's a superclass. And so the class that extends the other one is the subclass. The keyword that describes what class inherits, that's called extends. The keyword that describes what interface, okay, so that is a chapter 14 bit. We haven't talked about interfaces yet. We have, but it's been a while. That's implements. And the keyword that checks to see if an instance of, all right, so there's definitely some stuff in here that we haven't quite covered enough or covered recently enough. What is an abstract class? It's a class that's declared with the abstract keyword, duh. Well, how about this? A class with an abstract method. Both of those answers are true. An interface is one that's denoted. Okay, I'm skipping that one because it's about interfaces. Which keyword? Well, that's just a repeat of the other question. The keyword that specifies the superclass is extends. Which keyword specifies the interface? Well, alrighty. It's implements. You know that's the above answer, so select it. All right. Anyways, we'll be talking about interfaces again. Pantheism, polymorphism, or parallelism is when different objects respond differently to the same method call. That's polymorphism. You should implement what method to allow objects to be compared to each other? Well, you wouldn't use constructor to compare objects. You wouldn't use toString to compare objects, although I guess you could. You could get two strings and then see if they are the same, but that'd be dumb. We'd use dot equals to compare two objects. And so if we want to make our objects comparable to each other, you have to implement a dot equals method. What method will convert the object's data to a string? That one's hard. toString. Constructors are invoked by the new keyword. Does that sound true? Sounds good to me. Can they assign private instance variables? Yeah. Are they usually declared public? Well, if you declared a constructor as private, the only thing that could construct an object of that type would be child classes. The only thing that could call it would be child classes using the super call. And there may be a time when you want to do that, but you could accomplish the same thing just by making it abstract. If you made a constructor private, then nothing would ever be able to make it except child classes. So I think all three of those are true in my head. How do you call the constructor of a superclass? When do y'all tell me what's the keyword that calls the superclass constructor?
Super.
Yep, super. The @override annotation is used to validate, to verify that the method that follows it actually does override a method in a superclass. And this is a true statement. Using it is optional, but it's a very good idea. So NetBeans is constantly suggesting adding it. All classes, including the ones you write, extend the object class. That's very true. Even though we don't use the extends object keyword, that's where all the methods like dot equals and toString are ultimately defined so that they can be overridden, so that Java can guarantee that every class can have a toString method and have an equals method. They just provide lousy ones for you so that you're, compelled to override them, but it provides them. If data private, methods public is a concept used in encapsulation, if you're going to use subclasses, you might make the data protected instead. I'm just going to delete that because I'm really peeved that Java does not follow the C++ rules for what protected means. Apparently, there's nothing that protects the data from the child classes except for marking it as private. It's just either all or nothing. I like that. That's definitely a typo. Their levels of access protection are public, private, and protected. That's also true, but again, I may just delete that reference to protected. So, and a private member is only accessible by code within that class, but a protected, okay, that's another one that has to be deleted. Great. 3 questions that have to be deleted. It's going to make it an awfully short quiz over a complex topic. I'm going to go ahead and mark this as not published because I feel like changing it up a little bit before y'all take it. If there's anything else that needs to be added to it. And surely there's something else in chapter 14 because anyways. So I'm going to yank that away from you. Don't take it yet. All righty. So any questions over the homework or the concepts? It's too bad that the homework doesn't explicitly have the concepts, but I don't feel like making the homework assignment create a new Pokemon, right? That'd be pretty easy and just pretty much like, the last homework assignment that we did over Inheritance, where we created birds, right? So, could we, I definitely want to give you the piggy bank class, and I don't want to put 2 homework assignments on you. So going to leave it alone. We're just going to go with the piggy bank class, even though it's not specific to this chapter, right? It is object-oriented programming because you're creating a class. It's just not using inheritance or interfaces yet. All right, are there any questions? I'm going to go and make the Dropbox.
No questions here.
All righty.